Every year, our planet completes one full orbit around the sun. While that might seem like a calm, predictable journey, in reality, we're already racing through space at incredible speeds. But what if we decided to take things up a notch? Actually, scratch that. What if we cranked it up to the absolute max? Let's turn Earth into a planet-sized spaceship and accelerate it all the way to light speed. What would that do to our planet? Would it become unimaginably heavy? What kind of chaos would unfold if we started orbiting the sun at such an insane velocity? And most importantly, what would it feel like to be standing on the ground while all of this was happening? Well, get ready. This is What If, and today we're diving into a mind-bending question. What would happen if Earth orbited the sun at the speed of light? Breaking the speed limit. First, let's talk about just how fast we're aiming for. Nothing in the universe moves faster than light. It's the ultimate speed limit. Light travels through space at a staggering 300,000 kilometers per second. That means the moment a particle of light leaves the sun, it only takes 8 minutes to reach Earth. 8 minutes to cover 150 million kilometers. And light reflecting off the moon? That's basically instantaneous. It takes just 1 second to reach your eyes. That's how fast we're talking. But here's where things start to get complicated. You can't just press the gas pedal and accelerate an object like Earth to light speed as if it were a race car. The laws of physics don't work that way. As Earth gets closer and closer to the speed of light, something bizarre happens. Its mass starts increasing. The faster it moves, the heavier it becomes. And if it somehow reached the speed of light, its mass would become infinite. And here's the problem with that. Moving an infinitely massive object would require an infinite amount of energy. And as far as we know, that's impossible. Or is it? Earth is already zooming around the sun at a speed of 30 kilometers per second. And while that might sound insanely fast, when you compare it to the speed of light, it's barely a fraction of a fraction. To put things in perspective, our planet is moving at just 0.01% of light speed, a tiny, almost insignificant fraction of the cosmic speed limit. So, if we want to crank things up to light speed levels, we've got a long, long way to go. But hold on, don't get ahead of yourself just yet. The road to light speed is anything but simple. Because even if we only slightly increased Earth's orbital velocity to 42 kilometers per second, we'd already be in serious trouble.
Why?
Well, at that speed, Earth would reach its orbital escape velocity, meaning we'd be moving fast enough to break free from the sun's gravitational pull. Instead of orbiting our big, bright star, we'd be flung into the depths of space, turning into yet another rogue planet, drifting aimlessly without a home. Of course, we wouldn't be ejected immediately. We'd first cross the solar system, passing all the planets along the way before eventually being hurled into interstellar space, never to return. At this speed, it would take us about 3 years to reach Neptune, leaving behind the inner planets and speeding through the outer solar system. And if we got really unlucky, well, Earth might end up smashing directly into Jupiter. For a brief moment, that might actually be a breathtaking sight, our planet hurtling toward the gas giant's swirling storms. But don't get too excited, because that view wouldn't last. A collision with Jupiter wouldn't just be catastrophic, it would obliterate Earth, reducing it to nothing more than cosmic debris. But let's say we somehow avoided crashing into anything. Instead, we'd continue our lonely journey through space, drifting further and further from the only home we've ever known. And without the sun's warmth? Well, Earth would freeze over, becoming a cold, lifeless rock. Okay, so that plan didn't exactly work. Let's try something else. What if, instead of getting flung into deep space, we somehow managed to defy physics and keep Earth in its orbit around the sun, even as it accelerated to the speed of light? Well, first things first, to speed up an entire planet to that insane velocity, we'd need a truly unimaginable amount of energy. How much energy, exactly? Let's put it this way. If you wanted to accelerate just yourself to 90% of the speed of light, you'd need as much energy as the entire world consumes in 5 days. Now, imagine trying to do that with an entire planet. So, Where in the entire universe could we possibly find enough energy to accelerate an entire planet to light speed? Well, if we're looking for inspiration, our best bet would be to take notes from some of the fastest moving objects in space, hypervelocity stars. These are not just ordinary stars, they are extreme speed demons of the cosmos, reaching velocities of up to 33% the speed of light. That's 1/3 of the fastest speed possible in the universe. But here's the catch. They're incredibly rare. Scientists estimate that there may be as few as 1,000 of these stars in our entire Milky Way galaxy. And the reason they are so rare? Well, they need a truly wild chain of events to occur. First, these hypervelocity stars don't just decide to speed up on their own. They get their insane momentum from one of the most violent interactions in the universe, a black hole collision. Here's what happens. Two supermassive black holes get locked in an intense gravitational dance, spiraling closer and closer, spinning faster and faster as they prepare for the ultimate cosmic showdown. As they reach incredible speeds, their combined gravity creates a slingshot effect, sometimes flinging nearby stars out into the universe at extreme velocities. And that's how these stars reach 1/3 of light speed, by getting a gravity assist from one of the most powerful forces in existence. Alright, so based on that, the solution to getting Earth to light speed is simple, right? All we have to do is swing around a black hole or two. Easy, right? So, what's the worst case scenario here? Surely, traveling at light speed wouldn't be that bad, right? Well, think again. Experiencing light speed travel on Earth wouldn't look anything like what you see in the movies. Forget the streaking stars of the Millennium Falcon or the warp speed jumps of the USS Enterprise, because in reality, you wouldn't see any stars at all.
Why?
The Doppler effect. At these insane speeds, all the light traveling toward Earth would shift into higher frequencies, moving out of the visible spectrum and into the X-ray range. In other words, the entire night sky would go completely dark because the human eye can't see X-rays. And that's not even the worst part. These high-energy X-rays wouldn't just make the stars invisible, they would also bring some serious health risks. Long-term exposure to X-ray radiation increases your risk of cancer and can lead to severe health complications. Normally, we're protected from this kind of cosmic radiation because Earth's atmosphere acts as a shield, blocking most of it before it reaches the surface. But here's the problem. If Earth were traveling at light speed, that protective barrier might not hold up. And if our atmosphere failed, well, let's just say breathing would no longer be an option. But let's be optimistic for a second. Even if our atmosphere somehow managed to stay in place, it wouldn't stay intact for long. Because at these speeds, even tiny hydrogen molecules drifting through space would become lethal projectiles. Slamming into Earth's atmosphere at near-infinite velocities, these molecules would superheat the air, possibly burning it away entirely. In short, the very thing keeping us alive could be cooked into oblivion. And trust me, you wouldn't want to stick around to see what happens when Earth suddenly loses its atmosphere. But hey, that's a story for another what ifs.